Welcome to the example. In this question, we're given a data table with two variables. T is telling us the year since the college began, and E is telling us the number of students in thousands who are enrolled in that college. The first thing we need to do here is to create a scattergram. So you would want to set up your X and Y axis, identifying that your independent variable here, which is T, should be on your horizontal axis, and your dependent variable, which is the enrollment, should be on your vertical axis. And now we're going to look at the ordered pairs that we're graphing. So our first ordered pair we need to graph is 1, 10. So I go to a t value of 1, and I go up to a vertical value, an e value of 10. There's my first data point. Next I have 2, 13. So my t value will be 2, and my e value will be 13, right in between 12 and 14. And finally, the last value for this table is 4, 19. So I go over to 4 on the horizontal axis and up to 19 on the vertical axis, and I've got my 3 data points there. And now I need to construct a line. A linear model is going to be a line that comes close to or passes through each of those points. We're going to do our best we can to eyeball it there. If you're doing this by hand, of course, you would want to make sure to have a ruler. You get an absolutely straight line. Remember, once you draw your line, you want to put arrows on the end indicating that it continues forever. And you want to draw that line to take up most of the available space in your graph. Notice I didn't draw the line continuing outside this quadrant because outside this quadrant it's talking about negative t values. And if we think about what t means, it's the year since the college began. So before that college began, well, we know the enrollment couldn't have been anything. The enrollment was 0, so it doesn't make sense to extend this trend past the vertical axis. All right, and now let's look at the analysis questions they're asking here. First, they want us to predict the enrollment when it has been 6 years since the college opened. So we've got this number 6. We want to think about it, is that a t value or an e value? Well, the units here are years. That matches our t units of years. So this is telling us t equals 6. So we can go up to our line if we have t equals 6. And this is a good example of why you always want to make your line go as far as you possibly can to fill up your graph, because you might need it further. So let's go ahead and extend that line we had. I'm going to have to, let's see if I can do it here. We'll start it. All right, so welcome back. So we'll go from 6 all the way up. You can see our line is long enough now, so we're starting at t equals 6. We'll go up on to see where that intersects the line. When we get there, we look across to our vertical axis. And we're seeing we're landing right in between 24 and 26, so we'll say that's E equals 25. So we would predict that the enrollment would be 25, and then we want to think about our units. 25,000 students is our predicted enrollment. All right, and now let's look at the second question they're asking us there. Now they say, when will the enrollment reach 20,000 students? So I have a value of 20,000 students. That's telling me my E value. So it's telling me here E equals 20. So I go over to 20 on the E axis. I follow that over to my line and see where it intersects. And then I go down, and I see it's landing somewhere between 4 and 5 years after the college began. So we could say the enrollment of 20,000 was reached during 2004, or we could say the enrollment of 20,000 students will have been reached by 2005. So we could say by 2005, enrollment will have reached reached 20,000 students. Or another way to phrase that would be to say during 2004, enrollment will reach. And you'll want to look carefully at the wall map instructions to see what it's looking for there.